All right, now that you have finished watching that Eureka video, those things are so funny. Describe the work done and the energy changes when a ball is thrown horizontally.
So first you got to talk about the work, and then you got to talk about the energy change.
So we know that if I am, winding up to throw a ball this way, I'm applying a force on it, which is in that direction, and it's going to move in that direction. The displacement's in that direction, right? And so if when the force and the displacement are in the same direction, cosine theta is a +1. We have positive energy, right?
You've done positive work.
Positive work.
But
right?
You're right. Positive work, positive energy. What kind of energy changes happen?
So a positive energy change.
It goes from having no energy to what kind of energy?
Kinetic energy.
That's right.
Right. And then describe the work done in the energy changes when a ball is caught. So now I'm on the flip side over here, right? And the ball is being thrown to me, and now I catch the ball, and my glove is exerting a force that way, right? But the ball is going in this way.
So they're in opposite directions. The force and the displacement are in opposite directions. The cosine of 180 degrees is?
-1.
Negative work, baby.
Which means that we've got negative work, which means that we have a negative energy change.
Yeah, the energy changes goes from kinetic energy to, it's got some, to 0.
To 0, yes. And 0 minus a number is
a
negative number.
Negative work.
Okay, let's do a practice problem. Miss Moore climbs 3 meters along a ladder that's leading at an angle of 15 degrees to the wall.
Here's a ladder. That piece of tape is 1 meter. That piece of tape is 2 meters. That piece of tape up there is 3 meters. Whoa.
Okay, so Miss Moore climbs 3 meters long ladder. So here's my ladder, and we'll say
3 meters, and the angle is 15 degrees to the wall.
To the wall, that's important.
Okay, a diagram like this helps us understand. So basically you got the ladder back over there, and here's a diagram representing what we got. Okay, what's the question we're going to get in the slide?
How high is she above the ground?
Oh.
Okay, so this whole thing is 3 meters. So how high am I above the ground? I don't need to know that. I need to know this.
Yep.
Right here.
And what part of the triangle is that?
Well, this is the opposite. This is the adjacent.
Well, that's the adjacent side.
Yeah. So can't we just say, we can use our trigonometric functions, right? Yeah.
SOHCAHTOA, which one has the adjacent side?
Well, SOHCAHTOA is going to be cosine.
That's right.
Right, adjacent hypotenuse. So we can say, should I just cut straight to the point, or should I show them all the work?
Show them the work.
Okay, so
they might have forgotten.
Cosine of theta equals adjacent over hypotenuse. Cosine adjacent hypotenuse.
We want to know the adjacent side, so how do we get rid of the hypotenuse?
Multiply by the hypotenuse on both sides. And if you have to do this every single time, that's okay. Ain't no shame in the game.
Yeah, what happens is it cuts down on the mistakes you make. If you're not confident.
You are confident. Keep doing it, whatever you're doing. Okay, so we got 3 times the cosine of 15, and I get 2.9, we'll call it.
2.9 meters above the ground. And you can kind of see that. Here's 1 meter on the wall, 2 meters on the wall, 3 meters on the wall, and the piece of tape on the ladder is actually lower than the piece of tape on the wall. That's 3 meters on the ladder, 3 meters on the wall.
They're almost the same, right?
Well, yeah, it's just a little bit less.
Okay. If she has a mass of 65 kilograms, how much work did she do?
Well, you're doing work against gravity, yeah?
Yeah.
So you need to know the force of gravity that you're doing work against.
Okay, so I'm doing the force of gravity doing work. Isn't that 9.8?
Yep. Mass times acceleration due to gravity.
So it wants to know work, right?
Yeah.
And we know work is force times the displacement.
In the direction of the force.
And the direction of the force. Oh.
No, you're right.
Should I put in there? Yeah.
No, you're right.
And then my force that we just talked about. In order to find my force equals mass times gravity, and my mass is 65 kilograms. Gravity is 9.8 meters per second squared. So
it's going to be about 600 something.
Yeah, 65 times
635, I think.
9.8. 637.
Oh, close. Well, this is like the fourth time you've
know.
done this. I should remember that.
637 newtons times. And how come we don't care about this one? How come we're using this one?
Because the force horizontally is perpendicular. I beg your pardon. The displacement horizontally is perpendicular to the force, and the cosine of 90 degrees be 0.
Yeah. So I'm climbing up the ladder and I'm putting a force up. Right. My
Yep.
force is up.
Yep.
So we want the displacement up. If if my force is up, this opposite is perpendicular, and what Mr. Boykin just said is the cosine of 90. Cosine of 90 is
0.
0. We're
So
not doing any
0
work.
work when you go horizontally.
Yeah, we only care about the distance up,
Sweet.
and that was 2.9 meters, right? Okay, so my work here is going to be 637 times 2.9, and I get, that's a good number, 1,847.
1,847
1,847.
joules climbing up the ladder.
That's how much work I did.
It's a lot of work.
Why should she be frightened? All the way up there.
That's way the heck up there. Her feet
So
would
I've
be where the
done-
lights are in here.
Yeah, I've done all this work, and now that work is stored in me, just like in the video, right?
Right.
The monster guy that got hit in the nose, he climbed up to the very top. And I have all this work that's stored in me, and I have the potential to fall and hurt myself.
Potential for injury.
The potential for injury. And so that brings us to our next vocabulary word. Gravitational potential energy, UG.
Yep.
This is the energy due to the elevation above a reference point. Now we're going to come back to this,
Yep.
but this is the equation that you need to keep in mind.
Work changes energy.
Work changes energy,
And it's-
work equals UG,
It's a change in potential energy going from the floor up the ladder.
and that is represented by MGH.
Wait a minute. MGH. Didn't we do something like that just a
okay,
moment
okay,
ago?
okay,
Isn't that over here on the... It's over here
Oh,
on
it
the
is,
board.
it is. So the UG is MGH, right?
There's
Well,
your MG right there.
MG is right here. That's
And then we multiplied it times the H.
the H, which is just another word for distance. So MGH is basically the exact same thing as work. They're all the same,
Yeah.
right?
It's the work energy theorem.
Yeah.
Work changes energy.
Yeah, and we know that work is the change in kinetic energy, work is the change in the UG. There's a relationship with UG and kinetic energy, which we'll talk about later.
By the way, let me say something about that letter U. The capital letter U in physics symbolizes potential energy. Why is U potential energy? I don't know. Some people that are dead now made that up.
Well, it can't be P because P's power.
Power,
Because that could confuse people.
Yeah,
So UG is what we have left.
so that's gravitational potential energy.
Ugh, I gotta climb all those stairs. Right?
What about this reference point thing?
Oh, okay. So let's talk about that. I'll get the bowling ball right here. Okay, so your reference point. Your reference point is, what are you gonna make 0?
Yeah. Here,
What
hang on.
are you gonna make 0?
Let me move this.
Yeah, Miss Moore's tower of paper. So, if I set my bowling ball right here up top,
And you let go of it.
and I let go,
Ow!
so it has UG at
Wait a
the
minute,
top.
wait a minute.
Oh,
How are you
oh,
going to get that bowling ball back up onto the table, Miss
Now
Moore?
I have to do work to pick it up here and put it up top.
What happened to the work you did?
Well, it got transformed into potential energy.
And it has the potential for injury should you let go of the bowling ball. Ow!
And so this reference point, the question is, what are we going to make 0?
Yeah.
And you can do whatever you want.
Yeah.
What I would do in this situation is I would make UG 0 at the floor, right?
Yeah.
Because it's not.
That makes
high.
sense. It has no potential energy there.
0 at the floor, and then the UG, I do all this work and get it up here, would be max up top here.
Yeah.
We don't know what number it is right now. We could calculate it if we wanted to. if
And
we
we
did the math
probably
and
will
height.
before the year is out.
Yeah. And with that being said, the UG is at a max up here. Is it moving at all?
No.
So that means that our kinetic energy is zero.
Is zero. It's all potential. But let's not get into it.
Okay.
However, the thing about reference point and the beautiful thing about potential energy is you get to say where zero is. Zero could be on the floor. You could make zero up on the table.
And you know what happens if I was to walk out into the quad and kind of, you know, go down those steps, right?
Do that again.
Right? Right? And so if you made a zero at the floor, or I mean even right here,
Yeah.
you know, it would be negative.
And if you go out into the quad, that'd be negative potential energy.
Yeah. So you know we'll practice with this more, but
You guys remember the quad, right? Boy,
just a distant memory.
I know.
Okay, we'll do a little more practice here. See if you can do this. Take a shot.
You lift a 2-kilogram book from the floor to a shelf 2.10 meters above the floor. How much does the book weigh? How much work did you do? What's the book's UGG relative to the floor?
Okay, didn't we just do something like this?
Well, the weight is the mass times the acceleration due to gravity.
2 kilograms. And you said the weight or the force would be 2 times.
The acceleration due to gravity. We did do something just like this. We used your mass.
Yeah. Let me draw a picture first. We should always start with a sketch.
Yeah.
So floor is here.
Yep.
And we lift a 2-kilogram book from the floor to a shelf that's 2 meters above the floor. So my shelf is going to be up here. And my H here is going to be
2.10 meters.
all right. Oh, and then we have our mass up here. And let me just go ahead and calculate this force real quick. So now this is just like me calculating like my weight, my force. We're
Yep.
just talking the weight of the book this time.
You're going to take 2.0 kilograms.
I guess I probably didn't need a calculator for that. It's okay. You never be too careful. Okay, so how much does the book weigh? Oh, wait, yeah.
We just did
there
that.
it is. Sorry.
19.6
Yeah,
newtons.
So this is the weight. I didn't realize that was the first question. And weight is just mass times gravity. There we have it. Okay. How much work did you do?
Well, work is force times displacement in the direction of the force.
Our force is 19.6 newtons.
Your displacement is 2.10 meters.
Okay, so times 2.1, I get 41.2.
So that's how much work was done.
Okay, that's how much work is done. What is the UGG relative to the floor? Okay, so this is that reference point stuff we're talking about.
Yeah.
So let's go ahead. I like to make the floor 0.
We'll make the floor 0 in this
And
case.
it says, what is the UGG relative to the floor? So UGG is 0 at the floor.
And you did 41.2 joules work lifting it up.
And so the UGG is going to be, should I say like the max, or should I just talk about the number?
No, not just the number.
Okay, so if I do this much work lifting it up, that means that the UGG at the very top, work equals the change in UGG, is going to be 41.2 joules.
Simple, yes? You guys seeing how this stuff works?
Yeah.
Work changes energy. The kind of energy we're dealing with here is gravitational potential.
Okay, last question. If the book is on the shelf at 2 meters, okay, so it's up here, hanging out, and you are 1.65 meters tall, what is the book's UGG relative to your head? So I'm 1.65 meters, that's like
You're
right
taller
here.
than that, but that's okay.
Okay, so 1.65 meters
I'll
here.
draw a stick figure. All right.
Okay. So we want to know, so now our new UGG,
Relative to your head, that means 0 is going to be at your head.
yeah, let's cancel this guy out. This is no longer existent. Our UGG is now going to be 0 right here. How much is this?
Oh.
Let's do some math here. So the whole thing is 2.1.
Yep.
And we're going to subtract 1.65. Oh, that's wrong. 2.1 minus 1.65. I get 0.4. That makes sense, right?
0.4 meters, so it's 0.4 meters from the top of the head to where the book is at.
What did I say? Point what? 0.45.
0.45 meters.
Okay, so now we know that UG.
Is MGH.
So we know, well, M and G, we know that that is
19.6.
19.6.
I mean, you could do the whole thing again if you wanted to, but we lazy up in here. We lazy up in here.
And our new height relative to my head is just 0.45 meters. So you see how you can change where the UG is, like where the UG equals 0?
So what's the potential for injury should it fall on your head?
19.6 times 0.45, and I get 8.82.
8.82 joules. Not a lot of work, but it'll leave a mark.
Joules. Whew, yeah, that'll work. And that makes sense because this number is smaller than this number, right?
Yep. Okay.
Your homework, we're gonna go over how to
You know,
draw
you can do
some
that
of
in
them.
class.
Oh yeah, well, how to draw some of them?
Yeah, I do that in
Okay.
class.
All right, so your homework is gonna be page 255, right here, and number 6 and number 7. Okay, number 6.
By the way, here's the thing we just did when you look at it.
Yeah, if you're struggling and you want to look at some
Here's
words.
the 2.10 and 1.65.
Yeah, so
And
now
on page 255.
6 and 7.
Go
Okay.
to it.
Good luck.